So hi everyone, welcome to my presentation on the Aptus, which is a utility library for Scala. On the left here is a little mascot for the project, and I'm looking for a name for him. So if you have any suggestions, let me know. We're going to be watching over the presentation. So what is Aptus? It's Latin for suitable, appropriate, or fitting. And this is in contrast with perfect or clever. You can see in the middle of the screen roughly what it looks like when you use it. So it's mostly for basic things, but not only basic things. We'll see some more advanced things later. So how do I use it? So first of all, this is the GitHub repo. So you add this dependency. Latest version is 0.7.0. And you get started by importing either everything, which I actually now recommend against in favor of this, or you do like I tend to do, which is just extends this Aptus minimal thread. And then you can use extensions methods on it and call everything you need. I'm sorry. So the main goals of Aptus is basically to be practical and allows you to code defensively, disambiguate. I use it a lot for prototyping, but not exclusively. It just makes things a lot faster to develop with when you prototype. And it can also serve as a reference if you're curious to know how to implement things using utility methods. It gives you a starting point. What are some of the main non-goals now? Because that's actually quite important. It's not trying to be particularly clever. It's not trying to be particularly performant. And it definitely doesn't leverage the type system maximally. In fact, just the bare minimum, I would say. So when should you use it? So like I said, I use it a lot in prototypes in most of my offline applications. So I'm perfectly comfortable with a runtime error stopping my program, for instance. I use it more carefully with online applications. But me personally, I use it in almost everything because I know it so well. So so like applications in bioinformatics, accounting, finance, music. I have a little desktop assistant that's made written all in Scala that I use a lot of Aptus for, and basically all my other libraries use Aptus as well. So it's fairly well tried and tested. So why another utility library? This XKCD strip comes to mind because there's a lot of them out there. The standard library has been catching up to a lot of the stuff that I have added over the years. For instance, for the longest time, I had a construct called then, THN, which is now pipe, and if you import util chaining. I know also that there's something called a Scala toolkit, which seems great. I reached out to Simon, and I don't know if he's had the chance to look at it, but I'm sure there's some overlap here, and I'd be more than happy to adapt Aptus based on that. In fact, nothing makes me happier than removing things from Aptus because they've been added to the standard library. So this is the current dependencies that are in place. It's a little bit heavy, but I find that it's difficult to get anything done without those. However, I am replacing JSON with UJSON as it's becoming more ubiquitous in Scala. I believe it's now the de facto JSON library in Scala toolkit. And the other thing is enumeratum, which because of the new Scala enum 3, I'm a little hesitant to add in Aptus. And I'd actually be curious to get people's feedback on this. How do Scala 3 enums compare to enumeratum? I do know enumeratum does come in a 3.x flavor, but if I could do away with it altogether, that might be better. So why not stick to the standard library? Well, one of the aspects is conciseness. So for instance, on the left, we have a piece of code that's mostly useless and kind of weird, but it basically prints hello on the console and puts a space, fs24, and wraps this in a sum and then prints the result. Well, this is the counterpart in the standard library. It's fine, it's just a lot of typing, and for tired fingers like mine, this saves a lot of time. So what do all the following statements have in common? Let's see. I'll give you guys a few seconds to look them over. Okay, so they all basically do something I don't want them to do or don't expect them to do, or do something that I find is not obvious. So Aptus has got you covered. So the first one will actually split the string here and actually add two empty elements, as I think it should. Zip, same size, will basically error out if the two collections are not the same size. Now, me personally, I've never encountered a case where I was okay with two collections being zipped, being of a different size. I can't think of any use case, but I'd be really curious to know if anyone has a proper use case for that. So basically, I use zips the same size 100% of the time whenever I zip. And likewise with two map, for which Aptus has a force map that will basically error out. And I'm talking about runtime errors here. Like, this is not nothing fancy. It'll error out because there's a duplicate key here, which means that the first entry will be discarded. And I never want that. In cases like this, we should be grouping by, but we should never be discarding silently. Again, so if you can think of a use case for that, I'd be really curious. This one has force one, so whenever I expect there to be only one element, then I want this to be enforced. At least let me know if it's not the case. And the last three have more to do with making things clearer. So opt will make it clear that we're optionally getting a value. Force will make clear that we're forcing getting a value, and same for option. Let's talk about polysemy in the standard library. And just the funny thing is that I had a typo in my PowerPoint just a second ago where I had written polymessy. I thought it was a funny Freudian slip that I actually wrote polymessy. So let's consider these two guys. One is an option, the other one's a map. The standard library's way to get values from them is to use the word get. And in the first case, you're forcing the value. And in the second case, you're attempting to get the value, which returns an option. So if you do it with Aptus, you'll use force in both cases and there'll be no ambiguity, basically. So now let's go over the most useful and used constructs, at least in my code base. So the first slide will be about prototyping especially. So the first one is .str, because like I said, I'm lazy, I don't like to type toString. Then PRT, which just prints to the console and still returns a string. And because I'm lazy, I also have a shorter version called P, which I use a lot. And lastly, the P __, which prints hello, returns a string but exits. And I'm barely ashamed at all to be using this. I use it all the time. This one gives you a formatted view on the sequence. This one does it, but as a side effect, so it'll just print it out to the console. Print it out to the console, and this is a shorter version of it. I use that one quite a lot as well. It basically prints the string and put pipes around it so that it's pretty convenient when you're comparing multi-line strings, especially narrow messages. And lastly, this one's the assert, which is basically the same as ensuring from the standard lib, but the right-hand side basically allows you to do something with the value, which last I checked wasn't the case for the ensuring. Okay, now some more mundane one. The in sum we've seen earlier. In non-if and some kind of predicate. Now you can write the same thing with filter not, but I find it very unclear. Like if I see foo filter not says less than 5, I don't find it obvious at all what's going on here. There's also an in, list, set, left, right, anything like that. Little string manipulations like quotes, padding left and right. Max decimal returns a double. Me personally, I always have to look up that printf or that f interpolator documentation. I never remember what to write to get the right output. So this kind of takes it out of the way. And things like parsing date, time in general, basically. That's the same thing. I always have to look things up whenever I parse anything related to time. Okay. Onto the collection ones. So we've seen zip same size, which will error out if it's not the case. I have a couple more zip that are useful. Zip width is first. Zip width is last. Zip width index, you know that one from the standard library, but you probably don't know the very fancy zip width rank. Sliding pair, which is very convenient whenever you're looking at transitions. For instance, if you have a set of notes, a set of chords, and you want to see how they transition from one to the other. So I use that one extensively as well. Sliding pairs with next, which gives you an option. That way, if you only have a collection of one element, you'll still get something. And likewise with previous. Now, some of the forces that I've mentioned before. So the first two are obvious. Basically, if I'm expecting one value, then either empty or two or more will error out. This will give you a proper value. There's also a force option, which will work fine with either empty or one value and will obviously error out if there's more. Force distinct will be a no-op if there's no duplicates, but it'll error out at runtime if they are. You can also use it to turn it into a set. This one will error out, and this one will just basically give you the equivalent in a set. And there's also things like tuple 2, tuple 3, tuple 4, and so on and so forth. I'd be quite curious to know how people handle that in their code base. Like, it's, at least for me, it's fairly common to go from a sequence to a tuple. I always use that, so I'm curious to know if people enforce anything. Maybe Scala 3 offers something for this, I'm not sure. Little bracket here. A little bit more of data manipulation, simple things like count by key, which is just an alias for this guy. It'll give you a descending order version of that sequence with the counts on the left. If you don't have pairs, then you can just use count by self, which gives you the same thing. And then if you go into the data, you will be able to find more group by, left outer join, co-group, pivot, and so on and so forth. And it's interesting because I saw this question on Stack Overflow maybe a couple of months ago, and as some people are trying to join lists in Scala. So there you go. Aptus has got you covered here. Aptus offers a better way to do that, but we'll see that in a minute. Okay, let's just zoom in quickly on the sliding pair because this one's an interesting example, actually. So like I said, this one gives you this result. And let's look at the standard library equivalent. You'd have to call sliding, which gives you an iterator. Then you'd have to extract these two elements manually. And finally use toSeek because you presumably want to stay in the seek. Okay, now I want to go over a few more concepts and just want to give people enough time to read this funny thing. I have no idea if people find it funny since I can't hear you, so I hope I'm getting a lot of laughs. No. Okay, let's look at closable and its friend. So you'll notice the declosable. I'm actually surprised not to find this in the standard library. It's basically just this. It's an underlying type and a closable so that you can manipulate your type and close it whenever you want. And closable iterator, it's its most useful counterpart, basically. So it's basically an iterator you can close when you're done. And I should also mention a useful one, which is self-closing iterator, which basically just closes itself at the end. The items construct. This one's actually very useful. I use it extensively. So let's say you have something like a person with a name and an age, and you have a collection of persons called people. Then if you extend the items threat in Aptus, and you just give it the constructor, then you will be able to use a number of methods that will be kind of like if you were directly using the seek. And for instance, these three will remain in the context of the seek that you're using. So people, append someone, stays in people, and so on and so forth. And this is why I used endo map. Endo means that it stays within the thing. And conversely, exo map gets you out of the items. Now, I'm pretty sure there's got to be libraries that implement something like that, maybe with a fancy type name class like listoid or something like that. I'd actually be curious to know. But this is one of the most useful constructs for me, at least. So let's say now that we just want to add a little something to the person case class, has format default, and we just give it a basic string representation. Then we get a few more methods on the people items. That is also quite convenient. So yeah, I looked around and I found about 30 usage of items across all my projects. So I use them extensively in finance and accounting, like for transactions, in music, like I said, in my desktop assistant as events and templates and things like that. So surely there's got to be a counterpart somewhere in Scala standard lib or in the Scala libraries, but I haven't found it. A quick note on list map support. I find it a pretty underrated type, actually. Because like I said, this force map will make sure that you don't get duplicates, but you'll lose order with this because I believe it returns a hash map. Although for small maps, it's probably not. But if you have any big data, you'll definitely lose your order. So I use force list map a lot, and in my code, I tend to use list map more. It's probably less efficient for lookup, of course, but for what I do most of the time, this is more than enough. And it makes things like testing a lot easier. Aptus gives you a construct to build it because I don't believe that there's an easy one built in. And all the operations we saw earlier, like that are group-like, come with a list map version as well. Okay, now on to the latest development, basically dynamic data transformation, which is, for those familiar with my other library, Gallia, it's a very lightweight version of Gallia, basically, that I'm including inside Aptus. If you're not familiar at all with Gallia, the best place to start is that Towards Data Science article here. I also gave a talk on Scala Day in 2023, so you can find that on YouTube easily. So it does things like what you see in the middle, basically rename, increment, remove, add field, group by, and so on and so forth. As a side note, I am not set on the name yet, din. That din name, I used to use obj for obj in Gallia, and I'm not sure yet, so I'm open to suggestions. I like din because it conveys dynamic. So you can sort of think of din as a map on steroid, basically. So some of the main differences with Gallia, there's less operations. It's eagerly executed, so that means that there's no DAGs, which is a very big deal. It makes the code base a lot easier, actually. Putting a little asterisk, I'll touch on this in a second. Every operation is completely unaware of the schema, so it has no idea. It has no way of checking if adding a field is going to conflict with a field that already exists. Or if you remove a field that doesn't exist, it won't be able to tell you, so it'll probably fail at runtime. And it is not focused on performance at all, because there are way better tools out there for that, starting with Gallia. But if performance is really important, this is really not the library for you. Yeah, so about that asterisk here, there's a din z construct, which is basically an iterative-based din, and that one will be lazily executed, of course. But you're not going to be able to do things like forking, for instance. So quick example, you import experimental din, you give yourself some data called dins. Notice the S compared to the single object we saw earlier. Add a field, human, get them a little older, and for fun, just reverse their name. Then you can output it in whatever you want. I just use JSON here, but it's not a JSON specific library at all. So you could spit it out as TSV, for instance. This will give you something like that, a pretty, format pretty JSON. So it's a pretty printed version of it. Now, if you want to try it out, instead of using 0.7.0, just bump it up to 8 snapshots. So it'll look something like this. You will have to add the snapshots resolver and make sure you use that S01 dot. I believe it'll only work like this. This always confuses me personally. And sorry, I only had time to do the snapshot for 2.13. I'll try and finish it this weekend for 3.0. I had a couple of errors I didn't have time to look at. Let's look at things you can do with a collection of din or dins. So say you have a set of people like we had earlier, and you want to join companies with them. So you want to know who works where, basically. If they share the same, if they share one field only called name, you won't even have to put the via name. It'll obviously come with a lot of other operations like this. I only put group by in black because that's the only one that I put in the little snapshot. But all these operations are already implemented with Gallia, so it's relatively easy for me to extract them and reuse them for DIN. So it's not like I'm starting from scratch here. So what if my data is very big? Well, like I said, there are better tools for that. But if you do need to process data that's very big, for instance, you have a huge file and you're only interested in a couple of fields and you're going to be doing some aggregation on those, and that might still fit in memory, then the DIN-Z construct's got you covered. So like I said, it's backed by an iterator, and it'll offer some of the wide operations that you're familiar with, and it'll use what I call the poor man's scaling, which you can think of as basically the external sort, like new sort. I touch on that, I think, on the Scala Days presentation, and maybe a little bit in the docs on the README as well. But basically, there's a way to implement all these operations by combining external sorts. And it's not very efficient, but it'll do the trick. In the future, I'll create an Aptus, DIN, Avro, and Parquet, mostly because I already have them for Gallia, so that shouldn't be too hard. I guess I'll just discard the schema after reading it. I'll also try and put a JDBC and a MongoDB one at least, also because they're in Gallia already. So yeah, this will at least allow you to do a minimum of big data processing if you need to. And actually, the original idea for me to do Aptus DIN was to allow it to do some pre-processing and post-processing with Gallia. So a couple of things that weren't managed by Gallia, well, I figured you could do some pre-processing. So like removing nulls, for instance, or adding them back at the end if for some reason you want nulls in JSON. Not that I recommend it at all. So again, why should I use Aptus? It can save you time. It can save you a lot of headaches, and it can give you a starting point to expand from. And if you're interested, you can type this in, for instance, and if you go down the rabbit hole of split tabs, it'll basically show you how to use common CSV, which is obviously a bit convoluted being a Java library. Or same with this one, it'll show you how to use like the proper ISO standard and so on and so forth. At least the default one, which is the one we care about 99% of the time. So in conclusion, Aptus is the coding companion you've always wanted. I welcome feedback, contributions, with a little exception here, the DIN module, until I actually publish the 0.8 version, it's going to be too much work for me to work with other people. So I'll wait, and let's wait until we have at least one stable version. And integrations, if you want to add, for instance, a to from DIN, or if you want to extend, have some of your collection extend items, that would be really great. And if you have any questions, I think we have just a little bit of time, and you can reach me on all these. And depending on whether we have questions or not, I have a few more slides, so let's see.
Hi, Anthony. Great job. So we haven't had any questions yet, so you can go ahead if you had the additional slides.
Okay. Okay, I see someone's typing something.
Seems, yes.
Okay, never mind. So if a few more things, that one actually we did see. Wait. Oh yeah, actually, sorry, I just wanted to zoom into this one. Actually, the split by is one of my favorite, because this is, if you actually want to implement it in a way that I find is intuitive, you'll basically need to do this. Me personally, I never want to discard trailing items. I don't understand why that's the default behavior. Couple more things. Let's compare Aptus's way of doing this with the standard lib, which is not that much bigger, but a lot less obvious to me. It's a lot of that, the match syntax is a bit different. So I find like this one is an interesting comparison as well. Basically, the left-hand side reads more like English than the right-hand side. That's the bottom line. A couple of operations like map if. So for instance, this one's going to be only time 10 if the number is even. The pipe if is exactly what you would expect. It'll pipe it if only, it'll basically act on the value only if the predicate is true. And I also have all the guaranteed version of strings. So if I want to replace something and I want to make sure that it's actually replaced, I'll use replace guaranteed as opposed to replace if present. Likewise, things like strip suffix guaranteed is also a way for me to make sure that if I ask for something to be removed, it is actually removed. And lastly, the only thing that I wanted to talk quickly about is the DIN module. It's very interesting to have written Gallia before having written Aptus, because you'll learn a lot from data manipulation if you write libraries like that. And it's all the more interesting if you go from a much more difficult library to a much simpler. And there's certain things that I did not think about at all when I started doing the Aptus DIN version. Is that because I don't have the schema, whenever I do things like join, it's a lot more costly to know what keys are in my data set. And the schema inference is something that I took for granted. For instance, if I read up a JSON document, I took my schema inference for granted. But me personally, I don't want to deal with a double if the JSON document contains an integer. So I had to put in place a small schema inference and basically toss the schema that I don't use farther than that. I thought that was an interesting, that's just interesting aspect.